Assalamu alaikum. My name is Muhammad Wajaz Zulfikar and my registration ID is 16T37. In today's lecture, I am going to discuss fast Fourier transform for the 8 samples. In the last lecture, I discussed the fast Fourier transform for the 4 samples, and in today's we will look at the 8 samples. So first of all, I draw the circle as this is our circle. This is for the 4 point, for the 8 point. I get it as this is W80, and we will move in the counterclockwise direction. W81, W28, W38, W48, W58, W68, and W78. So 8W8 to 0 for it, we have the value 1. Here we have the value -1. This is J and this is minus J. At this point we have 0.707 plus J into 0.707. Here we have minus 0.707 plus J into 0.707. This will be the conjugate of this value, minus 0.707 minus J into 0.707. And in this we have 0.707. This is the conjugate of W7 of it. So minus J of 0.707. First of all, look at the example. We have the sample 1, -2, 3, 1, 2, -1, 2, and 1. This sample 8n is equal to 0. We have 1 value. 8n is equal to 1. We have 2 value, and so on, and till the n is equal to 7. So in digital signal processing, we know that the basic rule is divide and conquer. What we'll do here, we will do divide this into the real part, and divide this into the even part and then the odd part. If you have any query, then you can concern with the previous lecture. You will clear this concept. So what we'll do here, first of all, for each sample I will draw 8 lines as 1, 2, 3, 4. This is 4 for even, and then the 4 next line for odd. 1, 2, 3, 4. So first of all, this is for even value. This is for even value. And what will for even x of 0, then x of 4, x of 2, and then x of 6. And for odd value, x of 1, x of 5, x of 3, and then x of 7. This is our odd value. So what we'll do here, first of all, we will draw these 2 lines as connect 1 line with 0 line with the 4 and 2 line with the 6. Similarly 2 line with the 6. Similarly the case here with odd values, 1 with 5 and then 3 with 7, and same case here. What we will do here, we will add up the values here. At x of 0, what will have value? At x of 0 we have 1. At x of 1 we have value -2. At x of 2 we have value 3. 0, 1, 2. At x of 3 we have value 1. At x of 4, what we will have? We have the value 2. At x of 6 we have the value 2. And at x of 5 we have the value -1. And at x of 7 we have the value 1. This is our 1 value. So the formation become it as, here we have the sign, this is -1 sign, and then the similarly -1, -1, this is -1. What we'll do here, we will add up these 2 values. 1 plus 2 is equal to 3. Here we'll do 1 will be here, and then 2 will multiply with minus 1. 1 minus 2 is equal to minus 1. 3 plus 2 5, 3 minus 2 1. Similarly, minus 2 minus 1 minus 3, minus 2 minus 1 cross minus 1 plus 1, minus 2 plus 1 minus 1, and then 1 plus 1 2, 1 minus 1 0. This will give us the value 3 minus 1 5 1 minus 3 minus 1 2 and 0. And in the next step, what we'll do here, we will combine first line with third line and second line with fourth line. Similarly, like this, first line with the third line, second line with the fourth line, first line third line, second line with the fourth line. Similarly, the case here, we here have the value 3 minus 1. In this, we have the value W8 of 0 and W8 of 2. Similarly, for the bottom two lines, not for the upper two lines, for the bottom two lines, we have the value W8 of 0, W2 of 8. Similarly, W8 of 0 and W8 of 2. Similarly, minus 1, minus 1, minus 1 and minus 1. So what we'll do here, W8 of 0 has the value 1. 5 multiplied by 1 will be 5. And then W2 of 8 is minus j. 1 multiplied by minus j will become minus j. Similarly, 2 will multiply with 1 become 2, minus 3, minus 1. And then W2 of 8 value is equal to j, minus j. This is the value minus j. Similarly, this will become minus j. 0 multiplied by minus j will become 0. So what we'll do here, 3 plus 5 is equal to 8. And then next is minus 1 minus j, minus 1 minus j, and then the next 3 minus 5 minus 2, and similarly 1 minus 1 plus minus j plus j, minus 1 plus j. Similarly, minus 3 plus 2 minus 1, minus 1 plus 0 minus 1, and then minus 1 minus 3 minus 2 minus 5, and then minus 1 minus 0 is equal to minus 1. So in this, what we will do here, in the next step and final step, we will do here, I extend these lines as so. In this, I will combine first line with the fifth line, first line with the fifth, second with the sixth, third with the seventh, and fourth with the eighth line. Similarly, one with fifth, second with sixth, third with 7, and fourth with the eighth line. So what we'll do here, we here have minus 1, minus 1, minus 1 and minus 1. Here we will add up the values. Here we have W8 of 0, W8 of 1, W8 of 2, and then W8 of 3. In the circle, we already have drawn the values of these circles. So here we have 8 minus 1 minus j minus 2 minus 1 plus j. And in the next point, W8 of 0 is equal to 1. So 1 cross minus 1 is equal to minus 1. W8 of 1 is equal to W8 of 1 is equal to 0.707 minus j into 0.707. So this minus 1 will multiply this, as this will become minus 0.707 plus j into 0.707. Similarly, here I will put up this value here, minus 0, and then W2 of 8 is equal to minus j, minus 5 cross minus j is equal to plus 5j, and W3 of 8 similarly is W3 of 8 is equal to minus 0.707 minus j into 0.707. This will multiply by minus 1. This will become 0.707 plus j into 0.707. So this will put up, I will put up this value here, and then here we have the 5j. So again we repeat these steps. 8 minus 1 is equal to 7. Minus 1 minus j plus this value, minus 1 minus j plus minus 0.707 plus j into 0.707. We get here value as minus 1.707 minus j into 0.293. Similarly, minus 2 plus 5j, minus 2 plus 5j. Similarly, minus 1 plus 5j and 0.707 plus j into 0.707. Minus 1 plus 0.707 minus 0.293, and then plus j 0.7 1.707 plus j into 1.707. And the next thing is, here we have minus 8 minus plus 1. 8 plus 1 is equal to 9. This is value of here. And then in the next step, minus 1 minus j and minus 1 into 0 minus 0.707. This will become minus 0.293 minus j into 1.794. And in the next step, minus 2 minus 5j. Similarly, minus 1 plus 5j into multiply this value with minus 1. This will become as minus 1.707 plus j into 0.293. So this is our value, and we give this value as all this value put up in the sequence x of 0 and x of 1, x of 2, x of 3, x of 4, x of 5, and then x of 6, x of 7. This is our value. So this is the fast Fourier transform. The purpose of this method is to reduce our computation cost. We know in the discrete Fourier transform our computation cost is very much high, and then in the fast Fourier transform we reduces our computation cost to 25%. So this is the end of this lecture. If you have any problem, then you can leave in the comment section. I will be happy to address this. So thank you very much.